Hi folks, Howard here. Welcome to Complexity Unraveled. If this is your first time on this channel, we cover a wide range of topics from technology, megatrends, business venture, to macroeconomics and social issues. To put it differently, we are interested in topics that are complex in nature and of great relevance to the society. On this channel, no one will ask you to like, share, or subscribe, so please click on nothing, smash nothing, and buy nothing. If you share our interest in this kind of topics, please give us 15 minutes of your attention and we promise to make it worthwhile. There is this one question we got quite often. How many ideas you guys have buried over the years in your line of work? Quite a lot, to be honest. I mean, before stumbling upon one great idea, you probably have run past 100 bad ones, misjudged 10 good ones, and battled a few zombie ideas that simply refuse to stay 6 feet under. I'm not sure how you guys feel about this, but at least for me, sometimes it feels like living in a never-ending loop. Some hot shit was celebrated 10 years ago. Then the hype died down. For 10 years, there was nothing. 10 years later, suddenly, it begins all over again. The comeback of the new, old, hot shit. I mean, sure, things are changing all the time. The social environment, the technological capabilities, the contemporary zeitgeist, certain topic was just ahead of its time. But more often than not, it was buried and forgotten for good reason. I still remember the hype around BioChar from more than 10 years ago. It was just wild. So many people were jumping onto the bandwagon and celebrating the discovery of this magic ingredient that was used in the Amazon basin thousands of years ago. Using biochar to revitalize the degraded farmland to produce more crops for the growing population and locking the carbon dioxide in the process for centuries or even millennia. It checked all the boxes. But despite all the enthusiasm and effort, it didn't take off. 10 years later, with ESG being kicked into overdrive and pushed well beyond reason and rationale, you know it will come back. And here we are. Revisit the potential of biochar. Let's start with the basics. What is biochar? Biochar is often mentioned in connection with terra preta, Portuguese for black earth. It's a sort of dark and fertile soil which is estimated to cover more than 3% of the Amazon basin, something that the indigenous people used thousands of years ago. The discovery of this dark and fertile soil can be traced back to the 1860s, so it's definitely not some kind of new invention or new discovery. The existence of fertile soil in the Amazon rainforest was a significant archaeological finding, because it provided evidence that the Amazon basin is able to supply enough food for a large population of a higher developed civilization. Upon closer examination, the high fertility is attributed to the variety of organic matter in the dark soil. Bones, chicken manure, human feces, ashes, fish bones, and among them, the magic ingredient, the biochar. A term that is coined by Dr. Peter Reed in 2005. It's a charcoal-like substance produced by burning biomass under low oxygen level. Human ingenuity is something truly amazing. The indigenous people in Amazon used a rather simple way to produce biochar. They dig a large and deep hole in the ground, throw everything that could decompose organically in there, and then set everything on fire. Finally, the hole is covered with soil to create an environment with high temperature and low oxygen level. In essence, it was a primitive version of pyrolyzer. Until this very day, pyrolysis is still the primary method to produce biochar from biomass. Even though it sounds energy intensive, the modern pyrolysis is an autothermal process, which means an endothermal reaction, the absorption of heat, and an exothermal reaction, the release of heat, take place at the same time and leads to a rather high energy efficiency. In addition to biochar, oil and synthetic gas are among the byproducts, which could be further refined or used as typical fossil energy carrier. With all the basics out of the way, it's time to look into some potential benefits of biochar, which are surprisingly not limited to agriculture. In addition to improving the soil condition, increasing the crop's yield, it could also be used as supplement in animal feed or even qualified as negative emission technology. But first, let's go back to the root, the terra preta, the dark, fertile soil. How does biochar improve the soil condition? Biochar per se is not nutritious. It's not some sort of super potent magical fertilizer. Biochar is a stable organic soil amendment that could improve the soil properties in multiple areas. You see, to determine the soil condition, we normally look at three different aspects: the physical, the chemical, and the biological properties of the soil. And here are a few examples. Physical properties would be something like aggregate structural stability, aeration, or water retention. On the other side, nutrient retention, pH value would be considered typical chemical property. As of biological properties, we can name habitat protection, organic matter decomposition, etc. Biochar has quite a few unique properties. It has high porosity and a rather high surface-to-weight ratio. For instance, biochar made out of rice husk has a surface-to-weight ratio of 190 square meter per gram. When mixed in the soil, these unique properties make poorly aggregated soil less compact and lead to better aeration and water retention. But it doesn't stop there. One of the major challenges in agriculture is to make the nutrient in the soil available to the plant when the plant can actually benefit from them. So the timing is really the key here. Fertilizers can often only be applied early in the growing season before the crop canopy closes and the field operations become no longer feasible. Unfortunately, between the time the fertilizer is applied and the time the crop takes it up, fertilizer can be leached out of the soil by excessive rainfall, or consumed by weeds, or metabolized by microbial activity in the soil. To make things worse, just applying more fertilizer is not really a sustainable approach. Nutrient pollution caused by excessive use of fertilizer has already caused serious damage to our health, our environment, and our economy. In this context, another unique property of biochar comes into play: the so-called cation exchange capacity. I know it sounds a little bit complicated, but essentially it's the capacity to retain positive ions. It helps to conserve nutrients like potassium, ammonium in exchangeable form that remains accessible to the plant, and therefore improves the efficiency of fertilizer uses. Last but not least, biochar improves soil biological functions by inducing shift in the microbial community structure and composition. The biochar microbe interaction enhances the efficiency of various microorganisms such as growth-promoting rhizobacteria and phosphorus-solubilizing bacteria. It also protects soil microbes from deleterious effects of both organic and inorganic pollutants. Well, bottom line, the use of biochar as soil amendment has the potential to greatly improve soil condition and lead to significant gain in crops yield. A meta-analysis suggests the use of fertilizer could increase the yield by 26% in average. But if combined with biochar, the yield increase could reach as high as 48%. A 22% additional gain for the farmers. But it's not only beneficial for the farmers. Our society could also greatly benefit from this untapped potential, especially against the backdrop of the emerging food crisis and the increasing pressure on food security worldwide. In addition to agriculture, biochar could also play a role in livestock farming. I mean, you ever heard something like give up the meat and save the planet? A recent study done by the University of Bonn in Germany concludes that the European citizens need to reduce their meat consumption by a whopping 75% in order to achieve the climate target. We definitely will make a video on livestock farming in the future, but here are just a few things that are relevant to our topic today. The conversion rate from the calorie fed to the animal to meat is just insanely inefficient, as low as just slightly over 10%. But at the same time, almost half of the grain produced today is fed to the animal instead of human consumption. The large space required for livestock farming leads to less space for natural species conservation, and thus to the detriment of the ecosystem. And there's methane. Even though carbon dioxide gets all the blame for global warming, Methane is responsible for estimated 25% of the temperature rise. Livestock farming accounts for 27% of methane emission caused by human activities, and among all the livestock, the 1.4 billion cattle are responsible for 65% of all livestock-related emission. Ruminants instantly produce methane, which is significantly more potent in terms of warming the planet. Measured over the period of 20 years upon release into the atmosphere, methane is 80 times more potent than carbon dioxide. Replacing 1% of animal feed with biochar could reduce methane emission by over 10%, not to mention the wide range of potential health benefits for the animal, such as toxin absorption, improved digestion, blood value, feed efficiency, meat quality, etc. Considering a cow eats roughly 2% of its body weight every day, and the sheer number of cattle, this might become a significant demand boost for biochar, even surpassing the use as soil amendment. Despite the great potential benefits in both agriculture and livestock farming, the real reason behind the resurgence of biochar is something else: carbon removal. If you follow the climate politics closely, carbon removal or negative emission technology is finally gaining some momentum. During this year's World Economic Forum in Davos, it has been mentioned quite a few times. Even we have made a video on the topic. If you're interested, please consider to watch it. As for biochar, here is the simple logic behind biochar's potential as carbon sink. You see, biomass typically contains about 50% carbon, which is relatively quickly decomposed and re-emitted into the atmosphere upon decay. Depending on the way biochar is produced, it could retain between 10 to 70% of the carbon present in the original biomass and lock in the carbon for hundreds, if not thousands of years. With increasing attention on negative emission technology and the growing consensus on the necessity of carbon removal, not to mention the surging carbon credit price, it really should not be such a big surprise that biochar is once again resurrected. So, does biochar deserve this comeback? Well, 10 years ago, biochar didn't take off for a reason. And the reason is not that people were just so damn stupid and put out all the stops just to bury a brilliant idea, at least not back then. Today it might be a different story. Just look at Germany. The Minister for Economy redefined the term incompetence. He masterfully and gracefully explained to the German people, who are concerned with looming recession, rising inflation, and exploding gas bill, a company doesn't make money. A company doesn't produce. Doesn't necessarily go bankrupt, so just chill, there's nothing to worry about. While facing an unprecedented energy crisis, the German government still wants to get rid of all the nuclear power plants, which by the way work perfectly and produce 12% of Germany's electricity in 2021. And if you don't know, guess what? The same dude who's responsible for the German economy is also responsible for environment. You cannot make this shit up. This is really happening. But in the case of biochar, stupidity, insanity, and incompetence are not the reasons for the humble track record. There are quite a few legitimate issues. First and foremost, biochar is promoted as a solution to soil degradation and low crop yield. Although the interactions between biochar, different soil conditions, and the environmental factors are far from being fully understood. As soil amendment, biochar interacts with microbes, inorganic nutrients, soil organic matters, and exoenzymes. The results from field trials are less consistent, with outcomes spread across the spectrum. For instance, the microbial abundance in the soil from multiple studies shows contradictory reaction to biochar. Some positive, some negative, and some didn't change at all. In addition, the long-term effect of biochar in soil still requires more study. Even though radiocarbon dating suggests that biochar has been used by indigenous people in Amazon thousands of years ago, nevertheless tests as such don't reveal the initial quantity of organic matter applied to the soil, thus make the study of long-term effect quite difficult. To make things even more challenging, not all biochars are equal. The chemical composition and the physical properties of biochar are far from consistent. Depending on feedstock, processing conditions, and post-processing treatment, the properties of biochar vary greatly. For instance, rice husk has approximately 50% carbon content. Coffee husk, on the other side, 80%. Biochar produced from rice husk has a surface-to-weight ratio of 190 square meter per gram. But the surface-to-weight ratio would be only 70 square meter per gram if produced from coffee husk. Processing conditions such as pyrolysis temperature, heating rate, residence time influence not only the properties of biochar, they also have a significant impact on the output volume. The difference in output volume could reach as high as 6 times. Considering the rather small-scale production we have today, oftentimes produced with on-farm equipment or even small oven, it's rather difficult to ensure consistent product quality. Some people might argue the consistency problem could be easily solved with industrialization of the production, standardization of the process, and quality control of the feedstock. Well, the implementation might be a little bit more complicated than people initially thought. You see, all these measures could for sure bring consistency into the production, but for that, we need scale. But what about biochar's potential as carbon sink? That would be something at massive scale. The most often cited estimation suggests the maximum technical potential of biochar would reduce the annual emission of carbon dioxide, methane, and nitrogen dioxide by 1.8 gigatons. That would be more than enough, but we have to understand, while citing this rather impressive figure, the other half of the equation is often left out. To achieve that figure, we will need so much biomass that up to 556 million hectares of land would be required. That is almost twice the size of India, 16 times of the size of Germany. Due to this immense requirement for land use, is the practical feasibility of biochar as large-scale carbon sink rather questionable, not to mention the related issues such as land conversion, monoculture plantation, and the resulting impact on biodiversity and ecosystems. You see, the challenge with scalability doesn't stop here. The conversion rate of biochar from dry biomass is rather low, roughly 30% or so, which means 300 kilogram biochar can be produced from 1 ton of dry biomass. Depending on the crops, the biomass yield per hectare varies dramatically. For instance, a farmer would get 25 tons of corn silage from a hectare farmland, but only 1 ton of rice husk from the same land. A small on-farm pyrolyzer can produce up to 120 tons of biochar at 4,000 operating hours annually. To fully utilize the capacity, 400 tons of harvest residue would be required. If we look at the European Union, for example, 90% of the farms are smaller than 30 hectares. The relative small size of the farms and the high volume of required biomass make even fully utilizing the capacity of a small-scale on-farm pyrolyzer quite challenging. And by the way, we haven't even touched upon the seasonal effect yet. Crops with high biomass yield, like corn, can only be harvested once per year, which means all the biomass would need to be processed within a rather short time window. Otherwise, additional costs like transportation and storage would also need to be considered. In addition, long-distance transportation of biomass residue would be less meaningful due to the low volumetric density and low economic value. All in all, biochar might not become a climate solution at scale that we are hoping for. Although it doesn't necessarily mean it doesn't deserve a comeback, especially in less developed countries. For instance, the unique properties of biochar make it quite suitable for passive water filtration. Worldwide, 2 billion people are exposed to contaminated drinking water sources. In developing countries, 80% of diseases are directly or indirectly caused by improper drinking water. Cadmium, mercury, lead, and arsenic are the heavy metals that are most harmful to human health, and biochar can significantly reduce this harmful substance from the water sources. Of course, activated carbon offers a far more superior filtration capability and a wide range of off-the-shelf products. Nevertheless, not really affordable in many developing countries where people live under $2 a day. But thanks to the simple nature of pyrolysis, biochar can be made with cooking stove in their backyard, providing unraveled accessibility and affordability. In this day and age, people love to talk about big ideas. Big ideas that change the world, save the planet, or transcend mankind. Even though biochar is probably not a big idea as such, it has the potential to make some tangible impact on people's life or even save life. Thank you for tuning in and take care.